All right. Post that we're live and then we'll kick off. Let's get the editor open. Here we go. All right, so last stream, basically got all the material system in place in terms of the CPU side and the GPU side. So now we can edit a single file and start changing the material shader code. So right now, we just have the brick material running, but the brick material doesn't actually do anything other than just display the color of the brick. So I think what we might want to do is just make these cubes for now, or maybe make a ground layer underneath. I don't know. Yeah, we can do, or we can, yeah, I think we'll just restore the moving camera back again. Yeah, maybe we can just move a bit closer, perhaps, and make them cubes. Yep, that'd be cool. So today we're basically just, making this material brick shader work. We're going to double check the PBR code as well, make sure that's all good. And maybe do another material, or we might do the serialization stuff today for the materials so they save out to disk and we can read them in. I think we might do that. We'll see. So I think we can start off by just double checking the PBR code and make sure that's all good. Maybe. No, we'll just do the brick. It'll be quite easy. Let's do that. So if we go to materials.h, graphics materials.h, it's just got all the PBR code in here, and it has a shading structure. So you fill these in, input parameters in, and this will be enough to shade a surface. And effectively, there's a thing called a sampled material. This is what you need to generate when you do the per pixel brick shading. So we have this calculate surface color. It takes in that shading structure. The first thing it does is check the material buffer. Sorry, use this material GPU reference and the 3D UV and call this graphics material shade. This decodes the material reference, gets the proto material, so the shader the sub shader to run, then the offset into the words buffer where the parameters are, and then it will simply run that proto material. So it's just the shader code, and then it reads in the parameters for this material, and then we can basically do whatever we would like with them, which is super cool. So what I'm thinking about doing, yeah, so brick color 0, brick color 1, and then border color. So these are the parameters, right? It's just, it allows us to have many materials which use the same shader code underneath. So that's what a proto material is. It's just a set of shader code and a definition of parameters or properties. And essentially, we just take these parameters and allow, you can have different brick sizes, colors of bricks, the border between the bricks, they can change. So, it's pretty nice. So how are we going to do this thing? So effectively what we need to do is, so we have the UV, which is the 3D coordinate. We need to basically know what sort of brick index we are at three-dimensionally. On each axis, we need to know what index we're at in terms of the bricks. So we have the brick dimensions, and so we could probably do like a divide and then a floor, and that will get us the brick coordinate, if you will. Right, so that'd be like a UVec 3. You do like a UV. Now your UV can go anywhere, so actually it's going to have to be an IVec. Yeah, it can go positive and negative, right? So this would be your brick coordinate. It can be negative. It'd be like a... So you take your UV, divide that by the brick dims, and then I think you floor it. Yeah. So there's your coordinate, at least. So based on your coordinate, you can derive a color. Right, there's two colors to pick from. So what we could do is just shade between. Yeah, we could basically just solidly pick either color, and then maybe you'd want to have maybe a. Yeah, so we could probably hash the brick coordinate in some way. We have some cheap functions like the there's a PCG hash, but that one's not that. Yeah, I wonder what the let's see if we can ask the AI and stuff what are some good, good cheap GPU hash functions. Because there is PCG hash, but that one has a bit of a, it's not the wrong thing. Where's it got? Yeah, it says the PCG hash or the low bias murmur hash. This is what we've got already in the code base. These are the gold standard. Yeah, okay, well, I guess we'll use our PCG. Alright, PCG hash 32. We'll do that one. So PCG hash 32. Now the issue is that it's not three-dimensional, which is fine, because we just add it, right? Anyway, that's in core. Oh yeah, GPU shared, lovely. So what we want to do is that takes a UVec 2. So there was like a mix. Where was the PCG hash mix function? There's a function for that. I had it in a code base somewhere before. Right, so there's your magic numbers. Yeah, multi-dimensional, this is what we're looking for. Cross-component swizzling. Yeah. Yeah, it's in my old code base, that one. I wonder where actually, let's try and forget the one in the old code base. So be right, so we're looking for in the old code base, we're looking for PCG. This is our ones, right? Here we go. Yeah, let's pull these over. Here's what we want. Ah, spaces. Gotta have some tabs, you know. Alright, just gotta replace the U32 times 2s and all that with the ones in GLSL, such we have the operators. Actually, we don't really, yeah, anyways, too late now. So that would be UVEC2. UVEC3, and then UVEC4. Lovely. Now here we go. So we can take this hash function. Oh wait, there's a combine as well. The flatten, yeah, the flatten hashes. This is the ones we wanted. I remember now. We've got flattens in here. Don't think so. No, just flatten multiple dimensional coordinates. The flatten hash. Two UVEC3. There we go. Lovely. So the basic idea is we do this 3D one of that, then do a flatten hash times 3, something like that. Okay, so that'll get us a final value of a U32. Yes, it's a U32 value basically, and we then would like, so that we can call this the brick coordinate hash. Now we can use this to do some things with. So what we basically want to do is pick a color. So you pick the final brick color, and that will be effectively if the first bit is on, right, we can say use brick color 0, which gets passed in as a parameter, or brick color 1. So let's just start there and see where we get. Let's recompile them. And failed. So 141. Right, so we're going to convert to an IVEC2 explicitly, or 3, sorry. Then flatten whatever no matching overload or whatever it's called. Okay, why are you complaining? Flatten hash. Oh, spelled the flatten wrong. Flatten. So Boolean expression 144. Right. Needs to be converted to a Boolean. Cool. Right, so what we see now, I guess let me move the we should probably move the camera closer and make some of them spheres and some of them not spheres, I think. So we can do that. We go to game.c. We can find the, look for theta, I think. Yeah, so camera distance 30, let's do it at 8. Now we want to go into the mesh visibility render. No, the mesh visibility buffer fragment shader. So we're looking for here. Right, so if the instance is even, we shall make it do this sphere thing. And I've also got to carry that over to the shading code. So scene shade. So some of them will be spheres, some of them will be um, mm, mm, I guess I'll do a Rayverse ABB. Have we got one of those in the code base? Or an OBB? There must be one in here, right? Ordered ABB. Get one of these. Hmm. Alright, let's chuck it in here. So, else, hang on a minute. Oh, I'm in the wrong file. Scene shade. Right here. So, center position in world space. So, right. Let's call it R, I guess. So, RO, ray origin, world space, ray direction, world space. The half dimensions of the box. Where'd you get the radius? 1. Okay, so just do 1. Then vec3 1. Then border thickness of infinity. Cool. Nice. So the T min. Right, so T min and normal I think you want. Float T min. And infinity. Well, it doesn't have to be set, it gets set anyway. So T min is equal to hit dot. Yep. T min equal R dot X. And the normal is equal, in more space, is equal to R dot Y Z W. Then lovely. Right, that should be everything we need to have some cubes and some spheres to test the brick shader out on. So it's missing epsilon and where that's declared. Right, 128. Surface pos. Oh, it's the other way around. Cool. No S. Cool. Right, so we've clearly got some bricks now, although some of them look a little bit weird. The yeah, the depth value is a bit um we should probably keep we're a little bit close. We're definitely a little bit close. Go back to game.c. We'll go to probably 12. We was at 16 before. Then we went to 8. Now we'll probably arch the camera up just a tad. 12.5, probably a nice. Oh, maybe it's the wrong way around. I don't know anymore. 12.5, just a little bit. All right, negative 25 degree. Yeah, so there's something about these boxes. So I think this is meant to be something like a ray, a center position, take ray origin deal, where it's I gotta go back to where the code is being used. Ah, it's the other way around, of course. There we go. They're looking good now. So we should probably fix the sun to a certain place. Having changing times of days is not really going to be helpful to be programming a material. So we can go into the settings quickly and change the default value for manual sun direction to on. We can stick it at, well, it'd be nice for it to just be a little bit higher. So maybe 82. Right, it's still nighttime. 1. Yeah. Oh, okay. So 2.5. That'll make it midday, I think. Hang on a minute. Cool. So we probably want it at like 1.5. Apparently you got to run it twice for some reason. Cool. That's what we want. So now So we can keep this up and just watch it rotate. That'd be nice. And we can go back to the brick. Not the brick, the material.h, where the brick shade function is. So we use this hash function to sort of get us a hash of the brick coordinate and like the based on if it's odd or even, we pick a color, right? Now, I think the number of bricks, they're very, very small, that's for sure. We could... Yeah, so I think we want to do a border next. Let's put a border in. So the next thing we'd like to do is make a border. So how do you know if you're in the border? Well, given your divide by, that gets you a brick coordinate. So you do want a brick coordinate float version. And you want the sort of the fract of that, I think, right? So you want the sort of brick. So you want to know if you are on the border or not. So if fract, I think you call it fract, or is it frac in GLSL? Fract, okay, we're good. So fract, this will get you a value between 0 and 1, basically. So brick called F. Now, what you're looking for is if this is... Yeah, so if we minus 0.5, that makes it between negative 0.5 and 0.5. Then we can absolute it, right? And that will then... Now all we have to do is figure out there's this border dim, right? So if we say if it's less than... Right, now what you want to say is you want to sort of invert that to say 0.5, take that. If that is greater than border dim, or less than border dim, we're at the border. Right, but I think we do greater than, then we do the regular brick color stuff. And if not, we set color, so the final color. So color is equal to this brick color. And in this other one, the color is equal to border color. And then that should be what we want. Right, so we've got a bit of a problem here. So we want to say if all of them. So then we just use all. Wait. Yeah, this is a three-dimensional thing, isn't it? So you actually have to use greater than, and then you got to do, because GLSR doesn't have that operator for vectors, which is kind of annoying. But there we go. So all. No matching greater than. Yeah, you've got to do it with another vector. That's why. Right, brick color is not a valid identifier. Cool, that's fine. Okay, so apparently that reloaded. Although I cannot see anything. Kinda sucks. I don't know if it's going in here. We can test it by setting it to white. Still can't see anything. So I don't think it's going into here at all, this part at all, unfortunately. So something else is a bit wrong. So see if we can trace back the logic. So if we've done UV divided by brick dims, that will just provide you the brick coordinate as floating point. So you're doing fract of that, so that's going to basically drop off the coordinate, but only provides you the fractional part, so the 0 point, after the point place, basically, so it'd be 0 point whatever. We take away 0.5, that gives you a value between minus 0.5 and positive 0.5. Then we absolute it, such that we get a value from 0 to 0.5, so the negatives have basically just sort of like flipped to positive, right? So that means then your borders are going to be all close to 0.5. So that means we flip it the other way around by saying by saying 0.5 minus that value we've calculated. So now it means that close to 0 is going to be now going to be a border. So we're saying if all of them are greater, we're looking for all or any. We're looking for any. No, if all, I think it's, yeah. If all of them, yeah, if all of them are greater, then it's this bit here. So why isn't it working then? Well, I guess this is a case for printing, I think. It'd be nice if we can get like a pixel coordinate in here so we can test. If mouse app. Yeah, so for debugging purposes, we probably want to pass into the shading structure. Let's get that in there. Some kind of like and I guess we can do a whole sort of if def debug thing. We got that in the code base? Yeah. Which is cool. So this would just be this would be the pixel. Screen. Screen chord, something like that. So we'll definitely set that. Alright, so that'll be in scene shade. So we can just do shading dot this guy, and we'll set that to ucoord. So we'll just do the whole if def debug thing like that. So now inside shading, so the problem is yeah, what inside the shading struct can we get which will be useful? That is interesting. You can get the shading, the surface position in world space. So you could maybe do some materials which work with stuff like this. Maybe. Maybe not though. Yeah, it could be some fun things. So maybe we'll just pass in the whole shading structure anyway. It's not a big deal if we did that. What could go wrong? So we could actually just pass in the shading strut. That would be quite cool. Yeah, it'd be a reference anyway. Alright. Yeah, what is what is an imparameter by a reference or something? It means you can't modify it, right? Surely it's not by reference because everything gets inlined, isn't it? In is a classical pass by value. The value of the actual parameter will be copied into a form parameter when the function, but value will not be copied out. This is the classical pass by value. The value of the actual parameter is copied. Right. Copy, copy, back out. So that's the default then, isn't it? Read-only input. No, I can trust that resource, to be honest. Okay, it's the default qualifier. It just does nothing. It's still passed by a value. Either way, though, the whole thing gets inline, so it doesn't matter. I just wondered if there was a way to tell the compiler, hey, make this a reference if you can. If you didn't do that, I don't know, but no. So it's just pointless stuff. Pointless words to be written in there. So cool. So we want to pass in the shading strut. The whole material actually is on there as well, so we get rid of that. Shading.material. Oh no, you want the materials to be passed in manually here because we might have layers of materials. So okay, we'll sort that one out. Right, so UV. Right, so shading.uv, lovely. Right, I think that's compiled. Good, good, good. So what we'd like to do finally is do if is mouse at shading.debug screen position, then print me some stuff. Right, I think we crap. Oh, did that really not compile? Is mouse at screen coord. All right, lovely. Seems to be doing something. Yes, they're in the 0.5 range. Cool, so nice. So this means then if I move this within here and change it to 0.2, do we ever see that run? No. Okay, so why? Oh, so how big is the border? That's the question, right? Do we make the border like silly small then? What was that? It was in graphics VK border 0.01. Maybe that's why. So let's just hardcode border dim to 0.1. See what happens. Aha. Right, we can see bricks now. So that's interesting. It was just way too small. So if you got one, you should be seeing 1, 2, 3, 4, 5, 8, 9, 10. Yes, 0.1 is 10 bricks per 1 meter, but because it's one, that's where I gotta get it right. Oh no, sorry, I've not done it that way. That's the brick. I'm confused now. So the brick, yeah, I've done 0.1s on a couple of dimensions and 0.25. So because there's 0.1 on the brick dims, you should be fitting 10 per meter. But because they've got a scale of 1, you know, technically it's got a size of 2, isn't it? Because it goes 1 and negative. Minus 1 to 1, doesn't it? In this case. Yeah, because it's signed norm. Okay. Right. I think that's fine. So we should probably make the bricks a little bit. That's the thing, right? We can have different brick sizes. That's what's great about it. So let's make it like. Okay, so would like to make our border probably 0. This is the thing though about it. It's like, yeah, per meter it's 1, isn't it? Yeah, that's. Yeah, I'm just trying to think in terms of my scales of my object. So if the scale of my object is 1, that's like a half size basically, isn't it? So we should probably make the objects have a scale of 0.5. there would be a size of 1 overall. So where would I set that? That'll be the mesh, the test mesh. Right, let's scale Snorm. Half it. Right, then back to the border color. Hey there, Martin. Hey there, Martin. How you doing, sir? Welcome to the stream. How's things going? Yeah, so I think we can up the number of bricks at least. Let's say 2, 2, maybe a 3, 3, 3, something like that. Right, let's recompile that. Used to create Christian bait. Oh, used. Used to create Christian based games. Feel the question, but why emphasize this? Isn't it a general purpose engine? Well, it's because it's tied to my faith, you see. Because I made the business, Heroes Studios. So the reason why it's emphasized is because that's the goal of the business, right? So you get the idea. So that's the reason why it's emphasized. So that will be because in the model mesh, I assumed it was a size of 1. Somewhere. There it is. Okay, so the mesh fragment shaders done the same thing. But yeah, it's just test code, right? Reason why. Okay, so we should be able to bring the camera a bit closer then. So that'll be 8. Then we want to probably, the spacing between the meshes could probably be, where's the multiplier? What's defining the spacing? Do, do, do. Yeah, the multiply by 4 is half that. Cool, let's try that out. Here we go. Well, I've just buggered it up now. Right, it's getting there. So we can actually move the camera even closer. So you're a fan of institutionalistic logic? Not sure where that came from. But yeah, maybe I think that one went over my head there. Always try to. Is his name? I don't know. Right, this is good, except for I've buggered up the one of the shaders. I don't know which one it is. So let's just hunt it down. Not in here. Oh, the times by fours and all that. Right, I see. Yeah, it's all hard coded. Just the joys of getting up and going quickly just to get materials done. Ah, there we go. Looking good. This is what we want. Okay, so we've got ourselves yeah, this is cool. So at 0, 0 of the object, we get the border basically. That's the way it's decided to be done. We do have different brick colors, although the hashing could maybe be done a bit better. I don't know. Um, Maybe you want a floating point, like the amount of ratio you want of one color to another color, right? That'll be another fun parameter. But yeah, I don't know, because sometimes you might want them wholly one brick color and wholly another. But as you see, they're longer this side, right? And yeah. So the way bricks typically are is you would have like see if it will change. So you have a shorter Y. Right, crashed it. Yeah, it's all procedural bricks. So all done in shader code at runtime. That's the plan. So there's specific shader code for each material that you want, or kind of material. So yeah, all done. 3D coordinate, 3D bricks, 3D without sampling from a texture, all done procedurally. So you could do lots of weird stuff with it actually. And it's a very simple shader to do, right? As we've just seen. So yeah, as we're in the sort of material shading, this is all the PBR stuff. Just before then, we take in this material, and it has a proto material, which is basically the sub shader to run, and we just do a switch statement in here. We've obviously got to test in many of these and what the performance will be like. This is the reason why we're doing it early. And then we just basically extract some parameters out, and off you go, right? So they will definitely vary in complexity. And so this is the reason why we're doing it, is to test it out. But performance-wise at the moment, how's it looking? Well, you barely see it because it's not that many pixels. Clean shade, 0.13. So if we boost it up, it crashes. So where are we going? So red bricks also follow the normal of the curved wall. Did they already do that? The normal of the curved wall. They kind of do, don't they? Interesting. Hang on a minute. Yeah, because we've got these spheres, yeah? So you can actually get the normal of the surface. But then it's like, we already have that being passed in. We have the normal of the surface being passed in via the shading parameters. Then you'd have to pick probably a plane, but you could probably base that plane on like, yeah, that could be quite easy probably. So in shading we have the surface normal, but then like how would you? Yeah, I don't know how you do that. How would you split it up as a grid? Hmm. I don't understand how these spheres are looking like that way. Maybe they're supposed to look that way. Real bricks have individual persistent states. I wouldn't expect 100% accurate non-UV based bricks. Not sure what you mean by that. So real bricks have individual persistent states. Yeah. So they have like different, if they're different dirt or something like that maybe, or different colors. I wouldn't expect 100% accurate non-UV bricks. Following curves, etc., and having some kind of state on the surface. Yeah. No, you can always do different things, right? You can just do like a noise. I think that's the way you do everything, right, in graphics. If you need just need to add more noise, right? You can just you can do different noises and stuff. And also, we want to try to have procedural texture layers. So artistically, you could apply a dirt layer on top or like a moss layer, right, and paint it on, and that will be encoded into a per triangle face. I think we can do that. So you just need enough tessellation, I think, and it should be possible. That's the plan for the future. So we just got to build the individual materials, and then the sort of artistic tools on top can do it. So you could probably have a brush or whatever, I'm imagining. So you got to imagine this too with me. You could probably have a brick and a moss brush together, and as you're sort of like placing it on the surface, the it could be noise applying the blending weight of the two materials, right? Um, yeah, noise. There'd be a noise applied to the blending weight as you're brushing it down. Maybe this is what I'm thinking of how you get that sort of stuff. So yeah, you can do things like that, I think. But yeah, you're right. Some things to do with the bricks specifically, like the tones of the bricks and stuff, um, will have to be sort of individual. And again, we'll just use random numbers, hashing and things like that to get them a bit unique per brick, I think. You can proceed to generate a brick layout and then render it with a shader. Okay, so your sphere looks as if it's part of a straight wall that was gridded into a sphere. Yeah, that's probably true, isn't it? Just chiseled out. That's the way it. Yeah, I think it is correct. Yeah, because that would be the borders, I think. Yeah, because it's exactly on. Because those rings come from being directly aligned with a border. Yeah, that does look correct. So I don't know if you can make it face the outside of the brick of the and go around it smoothly as if they were placed with just the normal. Um, because you'd need like to proper lay it out, I think. But maybe you could have, yeah, I don't know. Yeah, it all depends on this sort of yeah. Here's the other thing as well. These are the UVs that are applied in uh these UVs are taken directly from being in local space of the object. But when I have an editor, we will be able to paint down specific UVs, right? That's the thing. On the triangles of these, the tessellated triangles of these objects, we can store different 3D texture coordinates and therefore get the wrapping rounds and stuff like this that follow the edges of the surface better. So that could be part of the system that maybe if you lay down, there's a brick wall, or there's a path tool, and the path tool will specifically patch up the UVs to match. So it does follow the what do you call it, the contours of the, is that what you the language you'd use of the wall? Yeah, the the this anyways, you guys understand what I'm saying. So it's possible. Yeah, awesome. So what can we do next? So the border sizes, are these looking a bit strange? Some of them look a bit thicker on the X than they do the Y. And that's because we're doing it based on division of the brick coordinate. So really it's becoming like a percentage really, isn't it? But I've done that one a bit wrong. The maths is a little wrong there. So rather what we'd actually want is brick coordinate. Yeah, so that 0.01 was probably a good size. So what we're looking at is if the UV itself is aligned with brick dim to some degree. I think that's what you're looking for. So what you're looking for is if brick dim shading.uv divided by border dim, so that's three-dimensional, then no, 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 no. Hmm. Yeah, so I'm thinking about like the the width here is the width of the border here versus the height of the border ends up being different for some reason. I haven't really looked on the top. I'm confused now. What happened there? Right, let's move the sun as well. It's a bit too bright. Oh, you know what? I've been writing as if it's degrees, but it's actually radians. So then what happens is it just ends up flipping. All right, let's change the time of day. Yeah, so yeah, they sort of look a bit off again. So it looks wider than it is. Yeah, the border thickness looks thicker the less bricks it has going across the axes. So why is that? Let's work out the maths. So brick ward. So when you divide by the brick dims, you're getting a sort of you're getting a ratio on how much it fits into that. Yeah. So what we would like to do, we could probably scale the border dim to be in accordance to that. Or move it into brick dim space perhaps. So what you'd probably want to have is like okay, so maybe just multiply. That'd be a tenth of this size here. Okay, let's try that out. Right, my CPU side code crashes most of the time when you hot reload it. Let's change the game, camera back. Okay. Okay, so I guess you multiply, but then it's gonna be super small in it. Right, so your border dim is gonna be expressed in like meters or whatever it is. Now, probably the other way around, maybe. No. So do you continue to have issues on AMD on even on Windows? I guess it's the less catastrophic because you realize the shader, right? No, I don't have any um problems with the AMD stuff on Windows as much as I did on Linux, where it crashed the whole driver and stuff like that. So that was mainly because my AMD RX 6600, that one had a hardware bug. I don't know what it was, but it would basically bring down my whole desktop when I got an infinite loop or whatever. And I think George Hotz said that he had a similar problem on one of some of his AMD stuff. But when I bought the 7000 series, so the 7600, the problem didn't exist. There was RDNA 3 and it went away. Now, but still, if I get like a device loss where I do an infinite loop or an index out of bounds, it does sort of freeze the whole desktop for about a few seconds and then it closes the application down. So yeah, it's not the smoothest experience, but it's definitely better than bringing the whole desktop environment down. It was doing before. So if your border dim is 0.1 and your brick dims are like 0.2 or whatever, now, was it, sorry, 0.01, and your brick dim is like one of them is 0.1. When you do, how many times does that fit into that basically, right? That's what you're doing. So it should be, so you're doing, no worries. Yeah, so you get 0.1, right? So then, so, wait, is it always showing this? Can I? So that'll be 0.1 on some of the dimensions at least. But then some of them are a little bit bigger, so it'll be like 0.01 or whatever it is, right? No, it'd be like, yeah, still, so that should be okay. So should be working, but it's not. So I'm gonna bring back the print code. The X is stuck. Why is that? Right, of course it would be, right? So, oh, they all have to be. Strange. Yeah, you kind of want to get the normal. Mm. Yeah, you kind of want to get the normal of the surface. No, you don't. Yeah, we just put our mouse on the plane here. The Z is going to be fixed at like 0.4. And it goes from a range of 0 to 0.5. 0 to border dim will be a border, basically. And anything above, if any of them are above that, then, yeah. So I think what we would like to have is if two or three out of the so you want to do this sort of greater than this, and then I've done this before in my other code base, but you basically want to convert back to some kind of integer one because it's Boolean, then sum all of the elements. So I think I've got this called sum elements. And then if the sum of the elements is greater than or equal to, or if it's greater than 1, where it goes now. I think that's what you want. Oh, sorry, it's just my current GPU is an AMD RX 7600, so it's basically the equivalent of a 3060, an RTX 3060 kind of. Hang on a minute, they're all a bunch of ones. Why are they a bunch of ones? Oh, wait a minute, this is if your brick is... Yeah, it's kind of a bit wrong. So it's greater than border dims if that... So if they're all inside, if they're all less than border dims, we don't just want any at that point. So you have like a two-dimensional plane. If your X coordinate or the Y. I think it's any, isn't it? So maybe it's not a sum. Greater than border dims. Maybe change it to a less. We change it to a less than in the print. So less than border dims. Let's just see what that looks like. Not really getting it shown up anywhere, which kind of sucks. So why is that? So your border dims, let's print that out. Alright, they're a bunch of zeros. That'd be why. So is it really that small? What's going on? What? Oh, you know what it is? The packing. That's the reason why it didn't work in the first place. It's the packing code. Right, so the issue is the range, I think. So brick. Alright, I see now. So if we bring the range, we should get more. Maybe we should offer more bits. Let's just do it 2 there. Should maybe help out. We could move the gloss around here and then do a 16. It's basically fixed point. Right, so some elements thing was wrong. I think we'll go back to what we had before. I forget what that was now. It was like a... I think that's right. Cool, finally. That's good. So now what we can see is the... no matter which axis these border dims are on, the X, the Y, or the Z, they're all the same width, if you will. Cool, cool, cool. So that's a good thing there. So I wonder what we can look at next. So we could add like noises and things to this. I wonder what's the performance, if you will. Let's get rid of the debug stuff. So this is a 4K screen we're rendering on, right? So just kind of get it close to 4K. So scene shade is looking at 0.52 milliseconds, but that's not obviously got many, you know, you got so many sky pixels and stuff like that. We really need like a big floor surface or have them covering more of the screen. But yeah, it's not ridiculously bad at the moment. But, it's only got a light as well. Single light source. But yeah, so we could have, you probably want to have some kind of detail. Take a look at some bricks, for instance. Uh, it all depends on the art style as well, basically, doesn't it? Really. But, you get sort of like this sort of texture sometimes, but it really depends on the brick. And you have you also want to sometimes make it feel that they're inset as well, sometimes. And different depths, because they're not perfectly laid sometimes. Maybe you do that with AO, basically. Yeah, so the ones in Tiny Glade, they're probably just individual. I think they're individual meshes. I actually have the game on my computer. Let's take a look at Tiny Glade here. So, yeah, they have. I think they're more in. Yeah. No, perhaps they're more. I think a lot of them are individual meshes and stuff. I'm not sure though. I've not seen it in like any GPU thing. It looks like they are, and they place them down. I was thinking about doing mine more like you've just got a mesh. But yeah, it seems like there are also like spaces between theirs as well and things like this. And it seems like you can only do that if you actually hand place not hand place them, but procedurally place them as separate little mesh instances. I think getting something like that as a shader is going to be a bit difficult. If just want something simpler, I can understand. I see what you mean. Procedural geometry rather than procedural shading. Exactly. Yeah. So I think they have a yeah. It all depends on what you want to achieve, basically, isn't it? So it all depends on the art style as well. Yeah. Yeah, I reckon we could probably find a simplex noise. I reckon. What does simplex noise look like? It's like a smooth noise, isn't it? Maybe. I wonder if we can apply that on top. It depends how many octaves you want. Maybe that's not the right thing to do. But, just pick a noise basically and apply it on top. Although it might add quite a bit of it. It might be quite expensive. Maybe, we'll see. Yeah, I've seen the wave function collapse stuff in the past. Although I don't necessarily, there's like a tile version of it, and you pick different tiles and stuff. Yeah, that's something you can do. I forgot. Hmm. Yeah, I forgot what games did that now, but I've seen it. So you can do procedural on one can do procedural on GP, right? It's just if one goes in the journey of generating bricks. Yeah, exactly. I think if we want to generate bricks, you do it like a brick wall. Doing per brick, doing it this way is probably not going to be that nice because you won't be able to make little gaps between them, have the imperfections and stuff like that. And then, but then again, you won't be able to bake in the AO and stuff like that, right? Potentially. Well, you can, but just be on a per brick level, but the gaps in between the bricks, you won't be able to do it. But it's interesting. Yeah, I think maybe having a brick material is probably not the right way to go. You might have something else, more of like a, hey, this is like a stone material. I think that might be the better way to go. But then, how would you do the borders? The borders between. It just depends on the set on the look you're going for. I don't really think in this game we're gonna have those classical house bricks anyway. You might just have stones and things, but then is there some sort of filament, if you will, between the bricks? How would they do that? This one here then. So that would be Instagram. Okay. The internet used to be so much better when I was a child. Back in my day, you used to be able to click on the image and see it full screen. And it needs to be higher resolution and not a thumbnail. I guess Sunnygate is passed for walls, and so on it, it could indeed make bricks follow the curve. Exactly. Yeah. Whereas this kind of shaded approach would work on absolutely any geometry. I see. Yeah, you could like. Yeah. I see what you're saying. Yeah, they have like a path basically, isn't it? But if you want it on a. Yep. But yeah, I think maybe we should not do brick, but instead maybe do like a stone texture, and maybe like a wood texture. Those will probably be better ones to do, maybe. Yeah, that's cool. But I wonder how they do this sort of filament, if you will. You see, I guess on these ones here, they probably have that as a whole material. I don't think they're individually placed, but I can't view the image a bit bigger. Let me see if I can find one. Better one. Like this one. Yeah, you see like this. They probably individually placed those. But where's the other ones? Yeah, I think these might be individually placed, but what they've done is they've got like a chiseled edge, if you will. I think it's more of a chiseled edge on the actual per brick, making it look different, perhaps. That's what I reckon it is. Yeah, see, here's some. I think they're more chiseled edges to sort of get that border look. maybe. Cool. Right, so maybe we should change it up and just do some kind of like a stone material, if you will, or maybe like a wood. Should get some inspiration on that. Curious to see what what the current approach looks like when you implement an offset for alternative layers. Oh, you mean like an offset for the Are you talking about as you go down the Z coordinate having some kind of offset? Yeah, I know what you mean, like rather than being perfectly placed. Yeah. So it's like an off by one. Do 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 do. Yeah, so how would you do that? You'd have like a brick coordinate. Right. So you basically take the XY and offset by half maybe. You have to only once. You have to say I think dot x plus equals 0.5. I think that's all you would need to do. Hang on a minute. That's only if brick award dot y. If floor brick coord dot y mod 2 equals 0. Something like that. I think. There you go. Kind of. Only on one face. Yeah, exactly. Yeah, but you'd have to get. And the Z. Would you do the Z as well? Yeah, I wonder if you can do. Yeah, something like that. Yeah, it looks much more traditional, if you will. Nice. Cool. So I think we should probably get some inspiration for maybe like a wood texture now. So I think there's the way you typically do a procedural wood is you get like a noise and you stretch it on an axis, and that gets you like a wood. I think someone done a 3D one before. I remember seeing it in the past. But it's gonna have a look. Bit of a browse. there was a 3D procedural wood I saw. Yeah, shaded toys searching is pretty bad. That's broken. Maybe these in the normal. I don't know. Texture is fixed in space with different grain cuts. Hmm. Yeah, it looks a bit too much. um. There was one that someone made. This is a 2D one. I think that's what I searched before. Yeah, here we go. So this might be it here. Yes, it takes in 3D point. So where's the wood function called? It should be called in here somewhere. Do 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 do. All right, wood P. So P would be Ray A box, and it's an out. Yeah, it's a hip position. So if we were to say 0.5 that, now we times it by 4. Right, I'm wondering if we're seeing a repetition anywhere. Let's times it by 128. Yeah, okay. Yeah, it seems like wonder how it's done, but it looks kind of cheap though. Basically, maybe it's expecting it to be in a normalized range. Yeah, it's an interesting one. I wonder what happens if they'll make it a sphere or just a different shape. That's pretty good. Something. Yeah, I'm thinking about like the reason why I'm thinking about it is like if you have a wall. The reason why I'm thinking about moving on from doing a procedural brick is that if you have a wall and you don't have a completely full wall of bricks, well, I guess you can cut the mesh out and yeah, so you don't end up. Hmm. Yeah, I think there's two ways to do it, right? You can either do the per individually place the bricks, or you could basically sketch the outline of the wall in a mesh and then shade that, so you can always cut holes in it basically. Yeah, so both do work effectively. Yeah, I think the material might be easier to work with as well, because if you did it the material way, it's literally just making a single mesh, isn't it? Rather than getting a load of meshes and aligning them right, which can always be a bugger, and also should be less computation, if you will. It's not a bad idea. Probably could work. Although this does kind of look horrible, so obviously not for a sphere won't be good, but yeah. Guess so. Yeah, perhaps we should keep doing it. So I wonder what else we can add to it then. So we could probably try a simplex noise on it. Just to sort of give it a different, more higher frequency detail, basically. I wonder what happens if we literally just take simplex noise and like apply it on top. Hey Perry, the news could be Wayland, maybe. You know, I actually already did Wayland Perry, but it's parked in my code base. Although it veers a bit more in from classical bricks, I'd be inclined to try and making the bricks square in the XY plane. No, so we can, it's completely configurable. You see we've got the brick dim parameter. It's the whole thing is, it can do square bricks, or, yeah, it can do square bricks, or, you know what, you could even do irregular offsets. That would be interesting. What does that do? Yeah, you could do irregular offsets. It doesn't have to be perfect. Triangle bricks. No, don't. Perry. But yeah, that would be interesting. But yeah, it's completely configurable. You see, so maybe, you know, I'd have to boot it. I have to close it down. But if we go to like, my whole code reload is broken. We want to move this to a file at some point. But yeah, we can actually make them square like this, right? So you can do that. You see, that's completely configurable, which is nice. Like 221 with the offsets you have, right. It does look odd on the sphere. So on the sphere you probably not do it on a sphere. We might build a mesh where the UVs get changed if you do it on a sphere, so it kind of wraps around and looks nicer. Or maybe we'll make it such that I'm not sure. Yeah, that might be another fun one. Let's go to the brick encoder. So I think we could probably add 0 to 1 offsets, basically. So Then they'll look more brick-like in north, south, east, west facing surfaces and square on the up-downs. Oh, right. So you're saying X and Y. I see. I'll give that a go. I'll give that a go. Brick offset. The brick offset can probably need to go up 0.5 at most. And you probably want to add 3 of them. And then if odd, if even. You probably 4 bits is 16 different values, isn't it? But if we try maybe we need XZ at that point. XZ, I think. Yeah, let's do that. That'd be kind of interesting. So you're saying like a 221 config. I'll give that a go. Um, Notice how I avoid mentioning YZ since I'm not sure if you have Z up or Y up. Right. Yeah, so my Y is up. Right, I see, yeah. You said, yeah, I noticed now. Oh. Yeah, I know people get in loads of arguments over that stuff, like, you know, which one is preferred. It makes sense sometimes to use XY being on the ground, but I try to stick to it being upright. It just depends on the game. Alright, here we go. Alright. Well. I completely bugged that one up. Why? What has changed? Yeah, I wonder. Yeah, so I've just added those new fields basically. Hmm. I wonder if it's impacted the... Alright, it's looking reasonable. Yeah, I wonder what's going on here. There's always print out the vector 3, which is the brick color. Okay, so it's only doing the border for some reason. Why? Thought... Take this up here. Right, what I'm looking at again, yeah, so this has to... So I changed the packing and this broke. Right, that's the thing that's strange about it. I changed the packing and it broke. I think that's what happened. So... those border dims are huge. There's a problem. But that's all the way over here. Um... Oh, yeah, because we changed it to 221, didn't we? Right, what did that used to be before? Okay. So that's why, it's because the border dim is around the same. Cool. I'll fix it. Right, so what we're getting is... that seems a bit bizarre. So 22... yeah, so we want probably one to have them square on top, basically. So if your XZ plane needs to be long. Try that. Yeah, lovely. Thank you, Davros. Nice. Yeah, that's better, isn't it? It's not bad. Lovely. Right, so I think let's try and put a bit of simplex noise on there. Let's make that look a little bit... Let's try and see if we can get some nice detail on there. You know, you don't have to have perfect borders also. Right, you can try and make it look a little bit more sloppy as well. I guess so, yeah. There's all sorts of different things we can do. We can make it seem like the border color, not the border color, the brick color, we can have another floating point in here, which is to define like how much of brick color 1 do you want? Right, brick color ratio, if you will. Like, do you go between one? You know, it's like a lerp basically, in a way. So you could take... So given if you land on a brick, how much of the time do you want it to be? Yeah, the problem is it gets turned into like a hash. So you probably want to make it like a... How many times out of 10? Or how many times out of 8, let's say? So 0 to 7. So actually bit pack it into 3 bits. Something like that, right? Do. So it's just a U32. And all you're doing is saying, see and 3 bits. Then if it's less than, so you probably want to call it like an edge. Maybe not the best word. Stick with edge for now. So if it's less than the edge, you select that one there, 0.1. Sorry, you select color 0 if not 1. So in here we can say brick color edge. If we put a higher number in like 6, that means nearly all of them will be brick color 0, but then brick color 1 will come in less amount of times, right? So that didn't work out as expected. If brick hash. Sorry, I did that completely wrong, didn't I? Yeah, did I? 7. Yeah, so that's 3 bits. That's right, it's the wrong bit filled this one. Right, seeing the value of 0 being passed in for some reason. Thought I said it. Might have to compile it again. Yeah. Right, I think we might have changed size of... There's an extra bit field in there now, I think. There's an extra bit field, that's why. There we go. Right, so now we've got more red than we have the other. Maybe we need to make that a little bit higher of a number. Less than 6. Yeah, I think that's alright. If you put it to 7 if you want it something like this. Just the odd brick will be grey. Probably just use a better hash function if you want it to be a bit more evenly distributed in a way. But yeah, cool. That's great. So you can choose the sort of between the two different colors in some way. That's very nice. So you probably also want to apply some kind of mm-hmm. Mm. So we could if we took simplex noise and applied it on top, you would kind of yeah. I've got a simplex in the code base. Just got to look for one. Hang on a minute. No, but there is one in the old code base. Here we go. So there is quite a bit there. I remember there being a more optimized version that was available. Or maybe we don't even have to use... We could use PCG hash and give it a go. Right, should we get a bit closer to a text, to a... I think if we change it the other way around, whereas in the mesh, we do not on that. And then in the scene shade, so we want to make it such that the cube is in the middle, is on the up, right, back. The up, right, left, and back, basically. Positions. I think that'll do it. And inside game, we'd like to make it such that the camera doesn't rotate. Let's try that. Ah, GLSL. All right, cool. So now we can probably move the camera a bit closer. So move the phi. And distance 4. Let's try that. Get a bit more of a full screen. Here we go. Nice. So we want to try and look at some kind of, make it a little bit, let's do 2. Okay, so with a 2, that should kind of be full screen, right? We went a bit too close. Maybe a 3 is what we're looking for. 3 is probably inside the object. Yeah, there's a bit of camera clipping going on. So I think we did 3.5. That's as close as we can get it, I think. So let's look at the performance of that actually. Let's do this. That's not so bad about a millisecond, I guess, for now. Right, so we keep this up. Or maybe not. The materials.h. So we find the brick. Now I'm thinking what we can do is across the whole board, we can kind of like take the brick coordinate, if you will, and we could get this hash and like we could get a 3-dimensional hash though. Well, we kind of already did, right? With a brick coordinate as a oh crap. That didn't drag and drop. Yeah, I think we've got to do another one. Nice, this is what I want. So I think we basically want to take the fract of, is it the fraction? The fractional part? Maybe not. Maybe the whole thing. So we take this, times it by, I don't know, 128. Then floor it. Maybe. I don't know. And then PCG hash it. So I guess it'll repeat every 256 bricks, which is fine. This will get you some kind of 3D hash. Now, could you use that to, let's just call it V for instance. Could you use that to change the color? Do we just do something like plus equal, just have a bit of a play. So V divided by U32 max as a float, cast it into a that's what you want, isn't it? Yes, that'd be 0 to 1. What does that do? So we are getting a bit of a noise now, but we did a U. Because we did a U, it's got rid of the sign. Right, so it's made this horrible. It's noisy at the top right, which is what I was kind of looking for, is some kind of noise. But yeah. Hey there, Plush. How you doing, sir? Welcome, welcome. So yeah, I think using the sign. See, I think what we may want is another sort of hashing function, which will like take. See, we could use sine for that, right? We could just say the sine of this value or whatever. That's what they typically do, right? But then you'll kind of see that. Hang on a minute. You'll see that sine wave quite easy, right? But I guess you would. Hang on. Yes, you'll see a pattern because it's based on the coordinate you would, wouldn't you? So how would you do a signed in? Awesome, glad to hear. Hmm. Yes, it does a clamp. So if I did a UVec3 to an unsigned, it would do a reinterpret, wouldn't it? Yeah, okay. Right. Cool. Right, so we've got some kind of noise. Now if we change the frequency, yeah, so if we change how much we times it, we change the frequency. So this kind of looks very grainy. This is what PCG hash will look like. It's kind of very grainy. So we could change out for like a simplex noise, and then it kind of adds more of like a softer, it's a gradient noise, right? It's a smoother. But you kind of also want a bit of grain as well. So, but your grain kind of wants to be more of a, probably more of a shadow. So I guess you could probably do like AO from this. I've not really got AO working, but we can probably have some sort of baked AO, maybe. And that can come from this. And then it will be independent of, yeah, it'll be done properly, right? It wouldn't be done via pre-baking it into the specular or diffuse, right? That's another thing about it. We also haven't done the gloss as well. We've got glossiness. So your gloss min and gloss max, you could probably base that off of this, but anyway. So to simplex or not to simplex? Now you do want it to be grainier. So if we take the, did we take the min or the max or something like that? And then, or we could flatten it like so into just a single U32. And then plug it into the AO side of things, I think. But then I don't know if there we go. So plugged into AO there at least. Now the thing is, I don't know if my PBR is done correct, so we can quickly dig into that, see if it is. So you're adding sort of a grain. And I guess when you move the camera, because it's very high frequency, it might not play very nice in some cases. Now with the grain, you probably want to have some kind of like max AO field somewhere. Oh crap. Let's do the other end plus 0.5. Yeah. But I guess if you've not done it right, what you could do is blend multiple layers on top. This would be a fun one. Right, you just do different frequencies, right, and then blend them all top into an overall like I don't know what would you do here. You could do hash mixes maybe, or something like that. Could you then reflatten it again? That'd be interesting. Could you do a so you're basically getting 3 different frequency domains and blending them together to try and get a fourth one. That'd be a higher. So it should maybe try kind of even them out maybe. Or you could blend them as floating point. So you can cast them into floating point. And then product them all together. Product elements. Vec. Vec4 divided by the product them all together, it's multipliers, get yourself a V. So it'll no longer be wrong one. Yeah, it's a bit different, isn't it? Yeah, I guess you're you could probably try and take an average maybe. It's another way of doing it, summing some elements and divide by 4. You're really seeing the grain there though. That's not as good as the other one was. Interesting though. So that was one way of doing it. Or it was this way. Interesting, isn't it? So V U, I'll call it, and V is equal to float VU divided by yeah. So maybe yeah, you're sort of already seeing the grain at this point. You're seeing the blockiness. Interesting. Yes, this one makes it look a little bit more blocky. As you can see the grain more there. Yeah, I wonder if you want to put it as AO or yeah, so the other approach would be to do simplex noise, so we can try that out quickly. 3D GLSL. I think I saw it, there was one. Was it this one that I saw? Snoise. Good old Snoise. Like a gradient noise. Alright. Anyway. It's broken down, the AI, no. Let's try it again. It just breaks down. Wow, I really did just copy paste it, didn't it? So there's simplex noise, fast, simplex noise, GSL. Because they can get quite complex, you see. I remember there being a GitHub for it. I think this is one I saw. Wow, we'll sketch our full float 4 value as well. That could be powerful. Although it's doing some of this stuff. Where's that declared? WGL noise mod. WGL noise, right. Been modified for Unity, rewrite, simplifications and optimizations, okay. Cool. So could probably use something like this, although what are these? What even is that? Right, specifically in his code base somewhere, so common maybe. Alright. I see. It shouldn't be too bad to port that. Give that a go. With the license as well, I guess. Doodle-doodle-doo, doodle-doodle-doo. Ready. So floor dot and all that. So we need these guys. There's the permute as well. Right, so rather than float 2, it'll be vec2. Rather than float 3, it'll be vec3. Rather than float 4, it's gonna be vec4. Right, so it should mostly work. There's just maybe one or two compile errors we'll get and we'll sort it out. Lovely. So if we try this one out, so instead of all of this, we can do simplex noise 3D. The input would be a vector 3. 3D coordinate would be the brick coordinate maybe. Maybe multiplied by a certain number. We could just try the brick coordinate for now. And we'll get back a vector 4. So we could just say v equals dot x. Now, right, nothing called dot apparently. Yeah, you got to do in HSL it has lots of implicit casts. It takes a scalar and puts it into a vector basically. You don't get that in GLSL. Right, so that's less than equal. Less than or oh, whoops. Cool. So frac is fract. And then right, so lerp needs to match the dimensionality of, yeah, it's a bit annoying. There we go. Hang on a minute, there's a vector 4. Nearly there. A Boolean 4. So it'd be a bvec 4. So less than gz. That'd be a vec 4. Oh, we're so close. It's doing multiply operators. Right, so why don't we just make it a gz? Right, I see. So let's do a UVec on that. Then you just convert that to U32. Oh wait, it's already done it. Ooh. Let's make that a IVec. Oh no, really? Less than 0. So less than... I don't get how this works in GLSL, so that's going to make a Boolean vector. And then it probably outputs -1. I don't get how that code works. So then it's doing a ternary operator on a vector. You can do that. On a vector of Boolean. Kind of bananas. Yeah, so what's happening is it's then selecting either 1 or -1 based on. So that's just a sine function, right? If it's 0, select. If it's the opposite of a sine function. So you're basically saying get the sine. I've got a special sign, so it does it. Yeah. But it's the opposite of a sine function. And then vec4, I think that's right. Cool. I think that's what it was doing. Right, it's just double check that. So if G is less than 0, put a 1. Yeah, so it's the opposite of the sign. Okay, so there's your simplex noise. What value does it return is the question. So if is mouse at shading dot debug screen coordinate print v. What sort of range do we get? Is it -3 to 3 for some reason? I'm not sure why that is. Where's the range of a simplex noise? Hmm. Why is it returning? Yeah, what sort of performance does that get you? Not that bad, actually. Right, it crashed. But yeah, so that value wasn't good because is it doing pi? 314. No, it's not, is it? Because it's going higher than pi. That's bizarre. So something's off with the function of it. Right, less than equal. What other ones are a bit different? Your lerps. Yeah, lerp will be fine. There's no smooth step. These should be negative signs though. So that was the only other thing, right? It was like GZ less than 0. Right, I see this person's repo, the one it come from originally. So already telling me the original value. It goes even higher. And 4. 1.5. So is 6 to 6. That one went above, even that went above. Is that 2 times pi or something then? What is it? I think the max is 2 times pi. For some reason. Can't put my finger on it, but it looks like that's the max. So if it goes above 1, then we're buggered, basically. Right. Now I just got to convert it to... I don't see it going above 1. Then basically you just want to convert it to 0 to 1. And voila. So the thing is about this though, is that the frequency of it is a bit too low. So you probably make it higher frequency. So I don't know, times by 32. So we can see it looks a little bit more grainy now, but it's kind of smoother. I guess you can combine more octaves. But yeah, so you can now, you could probably just do an FBM at that point. There's the, where have I done the FBM before? FBM. In the sky shade, that's it. Noise P. Yeah, you probably want to do something like this. But then it might get pretty expensive. But it's something to try out. Because it's going to inline, unroll and inline. Might be quite bad, but we'll see soon. So you're basically passing those configurable parameters at that point. So that would be your value, amplitude, vacuum. Narity as well, so that could be configurable. Okay, I see. So can you make it get smaller every iteration, or make it get bigger every iteration? I see. That's the gain. So you can pass these in, right? The amplitude, the Lacanarity, and the gain. Lacanarity and the gain. Okay. Let's give that a go. And the number of octaves as well. This is where you probably want to strut. Because, you know, reading that code back later on is going to be horrible if it's not in a strut. Something like that. Then basically just play around with these values here. Maybe you can provide some initial offset as well, I don't know. Yeah, so 0.5, that was 2, gain was 0.5, and then octaves was 6. Oh. Why are you complaining for octaves? Amplitude. Yeah, what's going on? Surely. Oh, 220. Ah, I see. Three, two, five. There we go. FBN stands for fractal Brownian motion, I think it does. It's, yeah, I forget, that's what it stands for. So it's fractal noise, basically. Yeah, that's the one. You can then also take your layers of FBM. You can take your result from an FBM and chuck that as an offset into your another layer of FBM, and that will be known as, that's known as domain warping. And you get stuff like this, these sorts of things. Yeah, it's pretty cool. So that's a bit too, this likes clouds and stuff. But yeah, this doesn't look well on bricks, unfortunately. But also it's really expensive doing this sort of stuff. I'm not sure what the yeah, as you see, it's just made my computer shader go from 0.5 milliseconds to 2, which is a bit too expensive. Material shading. We don't want that. So we want to probably reduce the number of octaves, that's for sure. 4 probably. And then try and figure out what does what looks nice basically. Interesting. The gain changes the amplitude, right, as you get in the octaves. So your frequency of P gets changed by lacunarity. So that means, yes, you might want to start it off at a bit more of a higher frequency, I think. Yeah, start off at a higher frequency, start off at 32. And then change that to 4. Cool. Maybe that's a bit too much. So yeah, we'll get you anything. So as you up the octaves, it'll make it softer basically, and it, you know, but then you're applying, yes, your amplitude, the lower that value, the more iterations you get, the lower that value is going to go, kind of, unless if your gain is 0.5. But if your gain is higher, is above 1, then if it's less than 1, it will go lower. It's greater than 1, it will go higher. So the first iterations are going to be wider. It'll be lower frequency, and as you go, it'll be higher frequency, right? So as you go through these iterations, so if we up the octaves, you'll see it will get softer. Yeah, it gets more of the higher frequency information, and yeah, so we kind of want to start on. Now the question is, right? You might want that sort of high frequency stuff. You want it to be there, but you want it to be softer and not very visible, right? So that means your amplitude must start off small, but the gain must be there to make it go bigger over the iterations, right? So your amplitude must be small, 0.1, say, maybe it's 2.5, but then your gain must be above 1 to make it grow. See, now it's softer, but as we up the octaves, the grainy bits will come in more, right? Cool. So, and the lacunarity will make P change more as we go. So, yeah, so you end up sampling the same position if you did that, but the more you up this lacunarity, the more of the position changes, if you will, I think, every octave, every iteration that you combine it in. So that could mean that you're making. Wait a minute, are you just making stuff? Yeah, it's kind of looking like it's making stuff higher frequency as it goes, but Yeah, 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 yeah. Okay, that's cool. Cool. So we don't want that, but it's hmm. What's the performance on that, by the way? 1 millisecond on a. I don't know about that. It could probably be done cheaper. If you take the octave down, it's not really changed much. Changing the octaves. We put up to 6, it made it 2, didn't it? Why did the lacularity? Anyway. Cool. Yeah, I reckon you could probably take this simplex noise and probably play around with stuff like the brick coordinate. Make them a little bit more uneven. You kind of want to reuse the same noise, if not it gets expensive, you see. Kind of looks alright. I'm not sure about the AO. The AO would be... Where did I learn it from? Well, I got it from... I knew of it already, but there's plenty of... You can Google what simplex noise is and see how it works, but basically it's a gradient noise, meaning that it will smoothly... When you sample at different locations, it will smoothly go from between values rather than being sudden changes. That's what gradient noise is. It's a smooth noise rather than a, a quick change. So simplex noise is basically a newer version of Perlin noise, and Perlin noise was what was used in Minecraft basically to do the map generation. So this is simplex noise, basically it's smooth. Yep. Alright. Yeah, there's plenty of resources online if you can take a look at it. It's done on a grid and it's pretty cool. Yes, I think the thing might be to play about with is how does it look if we move away with these different noises applied? Does it look alright? You zoom the camera in and out. How well does it look? Um, but it's kind of getting there. I want to play with the AO as well. You know, is that shading code correct? To you know, probably we can tinker around with these parameters as well. Can we find the best parameters for these? Is that, and also this AO value Is it a bit too harsh? Can it just be a little bit lighter? Maybe, right? I don't know. Stuff to play around with. So yeah, I think we'll do another stream on this brick shader. It'd be pretty cool. Just get all the parameters working, and then maybe have a couple of brick materials that use the same shader that do different ones, right? Maybe nice big chunky brown bricks, and there's these sort of red bricks, right, with some offsets, right? Um, just to show the versatility of this shader, basically. Yeah, I don't think we'll do that one. We'll keep the simplex, I think. Although, yeah. Although the anyway, yeah, things to think about. Cool. Right, so in the meantime, guys, there's Discord if you come and chat, and we also have a. If you enjoy the stream as well, you can also support the channel and get access to this code to run on your local Windows machine. And cool. Right, that's good progress today. I enjoyed that. The next stream will be on Thursday, 7:30 p.m. GMT. We'll also do one on Fridays as well, and one on Sundays. You can check the channel down below to see the schedule in your time zone. It should be there. Yeah. Cool. Awesome. Thank you so much for coming, everyone. I'll see you all in a future one. And my machine is frozen. Right. There we go. Right. Catch you guys later.